This is a short video on linearity, not the most sexiest of topics, but very important, and if it wasn't for linearity, mathematics would be impossibly difficult. So if we had a function of time f1 of t, and it would give us a Fourier transform of f1 of I omega, and another function of time f2 of t would give us another Fourier transform of f2 I omega, then by linearity, if we were to multiply the first function by a constant, the second function by a constant, and add both of them together and take the Fourier transform, it'd be the same as working out the Fourier transform of the first function and multiplying it by a1, and the Fourier transform of the second function and multiplying it by a2. So linearity really involves multiplication by a constant and addition. So here's a little proof of it here. If we were to look at the Fourier transform of a1 f1 of t plus a2 f2 of t, which is this here, so we take the integral from minus infinity to infinity of the function times e to the minus I omega t by dt. Then we can split this into two. We can take our constant outside the integration, the brackets. So we would have a1, the integral from minus infinity to infinity over f1 of t e to minus I omega t by dt, and the same again for the value of a2 being f of 2. So we can see from above that's just the same as saying a1, and this whole section here is just the Fourier transform f1 of I omega, and again this section here is the Fourier transform f2 of I omega. So that really is a little proof of our linearity, but to see the power of it we really just need to look at an example. So we'll look at an example on the next slide. So here's an example. We're looking at the Fourier transform of a function 2 times e to the minus 2t u of t minus 5. Well, by the properties of linearity, we could say that is 2 times the Fourier transform of e to the minus 2t minus 5 times the Fourier transform of 1. Now we know the Fourier transform of e to the minus 2t, we did it in the previous slides, the previous video, so that would be 1 upon I omega plus 2, but then we can just multiply it by this factor of 2 here, and the same again goes for the Fourier transform of 1 is 2 pi delta omega. We looked at that in a few videos ago. So then we can just multiply this by a value of 5. So finally we get 2 upon I omega plus 2 minus 10 pi delta omega. So that's all there is for linearity. A short video, but really quite important. So thank you for listening and goodbye.